On solving any question of maths, first of all think number of steps or any approach you are going to apply in this equation, in any question. This will help you out to solve a question in effective manner, and this is a better way to solve any question of math. Don't just write any blindly, like just any stuff coming in your mind related to that question, and just you are writing it down and just and get blocked at some step. Okay, so always try to think a approach which is going to take you at your answer or any certain desired step. Fine. Suppose in this question this integral there is given here. If I suppose here x cube plus s1 t, sorry, t cube as suppose, why I'm assuming, why you should think at each and every step, why should I do this? Okay, so this I want to tell before the video. I'm going to suppose here 2 to the power x minus 1 as t cube. Why I think I should explain. So if you suppose here 2 to the power x minus 1 as t cube, then the limits are going to have same with this equation and this equation as well. See, if we suppose as x equal to 1, so what will be t cube? T cube, t will be 1, t cube will be 1, so t will be also 1. And on putting sorry, and on putting x as log 9 to the base 2, as you know this is log property, this part will escape away, so this will become 9, and 9 minus 1 is t cube, I have assumed. So t will be 2, 9 minus 1 is 8, and t cube is equal to 8, so t is 2. So these limit tends to 2, and this is 1. So this will help me to merge these both integrals. So this was an explanatory part. First of all, I have to introduce a formula of differentiation, which is d upon dx of a to the power x, which is equal to a to the power x natural log of a. So applying this using this formula after differentiating both sides, this will become 2 to the power x natural log of 2 minus not dx, and this will be 3t square dt, equating dx 3t square dt upon 2 to the power x ln 2. Since d is t, if I assume as t as a variable, so 2 to the power x must not be there, so 3t square dt and 2 to the power x will be used from this equation. What it will be? 3t cube plus 1 into ln 2. Okay, so now moving towards the main expression which we have to solve, log x cube plus 1 dx to the base 2 plus 1, it became 2 t cube to the power 1 by 3 3t square dt upon t cube plus 1 ln 2. After this, integration of 1 to 2 log of x cube plus 1 dx to the base 2 plus 1 to 2. This will be 3t cube dt upon t cube plus 1 ln 2. So, as I told, merging these two integrals 1 to 2 log x to the x cube plus 1 plus dx plus 3x cube. Since here t is variable and I have just changed the variable, so it doesn't matter what is variable. After all, we have to just focus on the expression and on the limits. ln2 sorry ln2. I will applying base change formula here. Since it is log having base 2, I want to make it in the base of exponential. Integral 22 1 upon ln2 is going to come outside. Okay, and this will be ln x cube plus 1 plus 3x cube upon x cube plus 1 dx. Now this see here we are going to apply integration by product rule. Here why I am going to apply this will also explain. I will separating this sum in x and 3x square upon x cube plus 1, and here x will be considered as first equation and this will considered as second equation. Since let me explain how I this think. First of all, I have to discuss the product rule formula for this. Which is first into second dx, first into integration of second dx minus differentiation of variable. Since here is x, so here will be also x. I have chosen x, you can choose any variable. D of dx of first function into integration of second with respect to dx and whole integration of this dx. Okay, so how I thought that I should choose this term and I should break this in x in and 3x square x cube plus 1. See here, when I will using second term here, what is going to happen is x cube plus 1 will suppose as to be some variable, suppose v. Then what, after differentiating we will be getting 3x square. So this will come ln x cube plus 1 directly, and first will remain as same itself. So x into ln x cube plus 1, this term will give this term, sorry, uh, if we suppose this term during integration as v, so we will be getting after differentiation 3x square. So this way, after supposing this, I got this after differentiation. So what I get, let me suppose it as a v. So I will be getting 3x squared dx as dv. So dv upon this will become v. So ln v, and ln v, we will again substitute v as x cube plus 1. So in first in this part, I x cube, this was integral free, so I have not to worry about. I have to check just this, why I have chosen this, since here is minus sign, and after differentiation of first, x will get x will escape, and this will give me ln x cube plus 1, which I already explained before, just recently will give ln x cube plus 1, which will be get cancelled from this term. Understand? Don't worry, I will going to do each and every step in with pen. So one upon ln 2, let us take it in a bracket, integration of 1 to 2 ln x cube plus 1 dx minus, sorry, plus first function. What is first function here? First function is x, here it will be x, and second function is 3x square upon x cube plus 1 dx minus differentiation of first, x will escape, and after let me write it, dy dx of x, and again integration of this 3x square x cube plus 1 dx whole of dx. In this whole function, limit is applied. It's not from 0, from 1 to 2. So in the next step, 1 upon ln 2 integration of ln x cube plus 1 dx plus this will be x, this will be ln x cube plus 1, okay, minus differentiate, this will escape, this will again ln x cube plus 1, ln x cube plus 1 dx, limit is from 1 to 2. There is one more bracket, 1 upon ln 2, 1 to 2 ln x cube plus 1 dx plus, after applying limit in this function, upper as well as lower simultaneously, on putting 2, we have ln 2 ln 9, 2 to the power 3 plus 1 is 9, minus ln 2 minus of, since this will become a definite integral, ln x cube plus 1 dx, bracket closed. See, I have eliminated this step, these two terms which are not integrated still. After applying log property, here will be 3, after changing 9 as 3 square, and uh, the square power will come outside. What is there will be 4 ln 3 minus ln of 2, 4 ln ln 3 upon ln 2 minus 1 is equal to, let me change a natural log as a log base 2, sorry, log in the base of 10. This will become 2.303 log 3 to the base 10. This will become 2.303 log 2 to the base 10. This will come from base change formula. You can see it if you have any resource of mathematics. It will be given there. This 2.303 will be cancelled. I am doing this just because I know the value of log 3 to the base 10 and log 2 to the base 10. Log 3 to the base 10 upon log 2 to the base 10 minus 1. So 4 into 0.4771 upon 0.30 minus 1. You can take here first two terms after decimal point for calculation. These two terms you can leave rest of the terms. So this whole part will be coming something like that, coming as 6 point something minus 1, this will coming come 5 point something. I'm not calculating in detail ways since I have left one concept, which is this one, greatest greatest integer less than or equal to. Through this, if you have read this before, this means that answer will also always be integer. How how we will decide which integer it will be? So it is saying greatest integer less than or equal to. So this integral is giving me answer as 5 point something. So greatest integer less than from this will be this number that is 5 point something will be 5 itself. Okay, if it is not coming in point, it is such suppose it came to be 5, then answer will be 5, since there is also mentioned equal to also. So fine, 5 point something something will give us 5, since there is mentioned greatest integer less than. This is the greatest integer less than 5 point any value till 6, not 6 is included, before 6 and after 5 any value is giving me the greatest integer less than itself is 5. So our answer is 5. Answer is 5. Okay, fine. Thank you friends for being here. If you like the solution, hit the like button, and want more questions explained in this manner, so subscribe my channel Mathera, and also press the bell icon to get notified. And also feel free to ask any doubt in the comment section. Thank you.